Welcome, everybody, to my presentation of JUnit testing project. We're going to be talking about JUnit, which is a testing tool used in Java. And let's get started. Okay, so the first thing we're going to talk about, how do you write hard to test code? We're looking for code that's hard to test. Now, hard to test, what do you think that means? I would say hard to test means that it's going to be very tedious and to test the code, and it's not going to be deterministic. What I mean by that is we're not going to be able to tell whether the code's working or not. So how do you write hard to test code, right? A couple things come to mind. Code could be monolithic, right? The code could be non-deterministic. And when asked this question on an interview, it is hard to answer, even though we ourselves write hard to test code. Making methods private is one of the examples. I'm sure we all have made hard to test code, each and every one of us. So let's see, what are the real issues that make hard to test code? So we're going to be talking about real issues. The real issues that make hard to test code, number one is mixing logic. So when we talk about mixing logic, we're talking about two different logics: business logic and the application logic of it. Now like when you're combining those two logics together in your code, which means you have classes dependent on each other, and when we have these classes dependent on each other, too many, and they're all from different sectors, it creates a very unmanageable code. Static methods is another reason why we'll have hard to test codes. Happens with procedural programming. If someone gives procedural code, it is very hard to test. Of course, if someone gives procedural code, it is very hard to test. And more issues that could make hard to test code would be deep inheritance. Again, these classes are highly dependent on each other. Global state, all these classes being thrown around in all these different boundaries of the class, and too many conditionals. When we're talking about conditionals, we're talking about if branches. We're talking about all just ifs, if else, things like that. Remember, we cannot test code from the main method. We cannot test code from the main method. I'm sure as everyone is well aware. So now we're going to talk about writing testable code. Okay. So some of the skills of testable code include good object-oriented programming skills. Good object-oriented programming skills. Now, there are two different types of programming. There's object-oriented, that I'm sure everyone's familiar with, and functional programming. Now, within functional programming, it is very hard to make a change in the system without one fully understanding the system and make it affect the whole system. So to add new things, for the code to be extendable, it's pretty hard. One of the so with object-oriented programming, we dedicate these classes. So now, if something were to go wrong with, uh, let's say we had student's age and that wasn't appearing, well, at least the whole student entity isn't just disappearing. It's just the age. We still have class, name, all of that. Another thing is dependency injections, which we'll talk about further. We have test-driven development. So we're kind of validating our tests when we're doing this, as we're developing the code. And this is a great quote that I got from my references or at the end. Again, a lot of this stuff, I have my own interpretation as well, and I made beautiful slides. So these things are not, what you're seeing on screen. Yeah, it's great, but listening is crucial. So the quote is, there is no secret to writing tests. There are only secrets to writing testable code. And I think that's a great quote. So let's move on to scenario tests. So the pros of scenario tests is we have really high confidence that it's working. A lot of coverage of the code. And it's pretty much impossible to get corner cases. The thing is, though, it is very slow and time consuming. It could be very flaky. It is not efficient most of the time to try to test functions in scenario testing because of its limitations. Uh, so, I mean, you're pretty much testing, like, how many scenarios are you really going to test, to be honest? I mean, yeah, it's good. Like, it feels nice to do it, but if you really want to know if everything's working, I mean, it's good. It's the benefits of it, and it should be used. But, it's not everything. There's more different types that we'll end up talking about. We have unit testing. Now, in unit testing, this is what we're really majority of the slides is going to focus on is unit testing. We can separate the system into subsystems and test the individual subsystems. That's amazing. That's how we were talking about the student example that I mentioned earlier. We have these different subsystems. Instead of testing the whole program, we test the individual sections of the program. Yeah, that's perfect. Test individual classes in isolation. Yep, and that's exactly what we talked about. Is like you could test each different set of class. If I have a student entity, I could test out the different classes within the student. It's almost as if you could separately test one thing without having to affect the whole system, which is the whole idea behind object oriented programming. Can simulate all error conditions, and developers can run these after each modification, and it's fast, no flakiness. So the progression of testing, we have scenario tests and large tests, right? And then we got test whole application within scenario and large test. They test the whole application by pretending to be the user. Basically, I just go on my program and I act like I'm a user and go through each and every single set of classes and operations that I would act as if I was the user. Slow and flaky, and mostly easy paths. There's the functional medium test. External dependencies are simulated test class interactions. So we're interacting within these test classes. We also have unit tests, which are the smaller tests. It's focusing on the application logic. It is very fast. No need for input output, and no need for a debugger. No need for a debugger. All right. So all test levels are important. I don't want to say that none of those are. All test levels are important. It's just not all levels have the same probability of a bug, of a bug. And because smaller tests cover less, we need more of them. And that's another thing. Testability is more important as you get more focused. If you're doing a unit test, when you test the class, it might have dependency with other classes. So to test one class, the class will make a bunch of classes. And now we fall into that same issue as when we were using static classes. And that's not what we're aiming for, right? We're not aiming for that same issue. We're falling right into it. So instead, we use a seam. The seam is perfect. It solves our issue when it comes to that. Now, a seam, it makes friendly objects, and to place seams in out code is hard, and most people have not learned it. There are two responsibilities when writing code: the object graph construction and business logic. When most people write code, they combine these two in their code, but we need to separate it. When you separate these things, testing is easy. So, and remember, seam basically equals polymorphism, which is a very great, a high talked about topic in this computer science. You should know about polymorphism, and seam is basically polymorphism. All right, so back to how do you write the original question that we started with, which was how do you write hard to test code? Well, how we would write, you mix object creation code and business logic code. We're creating the object and mixing that same code with how it's working. This will assure that the test can never construct a graph of objects different from productions, hence nothing can be tested in isolation. Nothing can be tested in isolation. We're testing the whole system, and that's not good. That's exactly how we talked about as functional programming. Like oh, I'm sorry, there's no K here. Let me do this. Uh, Erase functional programming. It is so hard to do this. So this is functional programming. It's not object oriented. So the takeaway from all of this is unit test is the preferred way of testing. It requires separation of instantiations of object graph from business logic under test. Okay, so now we're going to talk about a version of unit testing. Sorry, I'm going to just get a drink because I've been talking a lot. All right. Let me just see how long we're at right now. We're at 11 minutes. All right. Not too bad. So we're going to talk about a unit testing type. What we just talked about was unit testing. It was the logic behind unit testing, why we use it, and it's pretty much the fundamentals of unit testing. There's a bunch more testing out there, different things. We're going to talk about a type of unit testing now that's implemented in Java, and it's called JUnit testing, Java unit testing. Is JUnit for short. And we're going to talk about one of the things in JUnit testing, which are assertions. And all assertions are in this asset class that is provided to you. And this asset class can be imported by using this code. Not imported, but basically we're extending it. The asset class extends Java lang object. Now, this class provides a set of assertion methods used for writing tests. Only failed assertions are recorded. Some of the important methods of insertion classes are as follows. So we're going to talk about some of the important methods of this assertion class that's provided by JUnit, is JUnit testing. So we're doing void assert equals boolean expected. So it takes a boolean that comes in, and the boolean that's actual checks two primitives and objects are equals. Okay, so it's taking in two booleans. Void assert true boolean condition checks the condition is true. Void assert false checks the condition is false. It takes in one boolean condition. Void assert not null, it takes in an object of a type object, and it checks that an object isn't null. Void assert null object of an object checks that the object isn't null. That is just checking that it's not that it is null. Actually, yeah, it should be null. Void assert same object. It's the one object and two object. They're the same. We assert same message to see if the two object reference points are the same object. Void assert not same object one and object two is the same. Basically the opposite of this one. And void assert array equals expected array and results array. And then the asserts array equals method will test whether two arrays are equal to each other. So here's an example of using assertion. Okay, so we're right here. We import JUnit testing and we import static org JUnit assert. Here, let me take that away so you guys can see it. Arrays. Okay. So we got the public class for testing assertions, and then here's the annotation. We'll talk about annotations later. So we have test assertions, and now we have our strings. We have these couple string types. We got a new string ABC, and string 2 is also ABC. We have another one that's null. This one is ABC, and this one's ABC. Okay, and then we have two int values, 5 and 6. And string expected array, 1, 2, 3. Okay, and then resultant array, 1, 2, 3. Okay, check that two objects are equal. So it's checking whether string 1 or string 2 are equal, these right here, right? And it checks here. And it's great because the best thing is these tools are provided to us instead of having us debug our code and have to go through. Like imagine we had to try to write, okay, is this string equal to this string? And now we're writing all of that code. It's not just going to be this one method that we get imported from here. It's going to be code, code, code. Okay, is it doing it? Is it not? Oh man, I messed up. All right, let's check this. You know, I mean, of course, we could easily write code that could do this, right? There's also that, but JUnit provides it to us, so why not use it? I mean, at that point, I understand, like, why not just use it? So we have assert equals, and it's just checking whether these two string types are equal. Assert true is checking whether these two, if the value is less than this value. The assert false is checking if this value is greater than this value, which is not. And basically, you guys could get the rest. You have insert not null, assert not null. It's basically just doing all these different operations for you. The assert class, and whether two arrays are equal or not. Perfect. Okay. Awesome. So that's our example of using assertion. I mean, it's a great tool. It's one of the tools in Java in JUnit. So why not use it? Assertion's awesome. Okay. So let's check the next thing. So now we're going to talk about annotations, and I talked about annotations before. You see it right here, this at test, that's an annotation right there. So let's talk about annotations. Annotations are like meta tags, and that can add to your code, right? And basically, when we talk about meta tags, do you guys remember meta tags when it comes to different types of coding? It's meta tags are great, and apply them to methods or in class. These annotations in JUnit provide the following information about test methods. Right here, these annotations of JUnit provide the following of the test method. With methods are going to run before and after the test methods. Which methods are running before and after all the methods? Which methods or classes will be ignored during the execution? I'm sorry, just give me a second. I gotta drink more water. Okay, so we got these annotations. Um, the list of annotations and their meaning is in JUnit. So we got this list of annotations. Let's take a look at it. Let's see what we got over here. What do we got? All right. So the first list in the list is at test, and now we use the test to tell JUnit that the public void method to which it is attached to can run as a test C. Perfect. So we're telling JUnit that we can run this thing as a test C. We can use the at before tag. Now, several tests need similar objects to create before they could run. Annotating the public void method with before causes the method to run before each test model. So we're choosing what things get to run before and after a class. And it's just as simple as injecting these little things that JUnit provides for us. So if I was to just say at test, so if I have this line of code and I say at test right here, right? And I say before at test, let's say I have all this line of code, right? And that's for something, right? And I have all this line of code, and that's for something. And I have this line of code and this line of code. And that's for something I need down here. Well, to ensure that it's created before the test can run, I just inject that before, and I'm done. And now JUnit is basically taking this care for me. All right, let's erase this because I'm sure I'm gonna keep drawing with things. All right, we have the after tag. Let me get the pointer out. Pen. We got the after tag. If you allocate external resources in before the method, you will need to release them after the test runs. And a noting to the public void method that after causes the method to run after the test. So basically the opposite. Before class and annotating a public static void method with before class causes it to run once before any of the test methods in the class. After class, this will do the opposite of that. And then we have ignore. And at ignore, the ignore annotations will be used to test that the test will not be executed. Here we have an example of annotations. We import all of these for JUnit. Now we have the class JUnit annotations before. We're executing before class, executing after class, or executing in before class, in after class, these print statements. In before, so this is before, so before class actually comes before. So this is before, comes after before class. And after class comes before. Before comes before after class. After class comes before test. And ignore comes after test. Okay, so it goes before class, after class, before, after, test, ignore. Next, you create a Java class file named test runner right here. And now we import these statements, the test runners and the notification flare. Now in the public class for the test runner, we have the main method. And now our result object with a value result is the JUnit core dot run classes. And now within those run classes method, we're putting in the JUnit annotations class. If for failure types, result goes to get failure types and system prints failure to string. Or a printout was successful. So let's talk about basic unit testing. Alright, so with basic unit testing, it's an example of how basic unit testing works. We have public class myUnit. Alright, we have the class myUnit, and now we have public string concatenate, string 1, string 2, so we're concatenating these strings, we're just combining them. To test the class, I need a unit test that tests each of its public methods. The class only has one myUnit method, concat. So we have concat. Unit tests are implemented as classes with test methods. Each test method usually tests a single method of a target class. Sometimes a test method can test multiple methods in a target class, but it is too big. But if it is too big, you split the test into multiple tests. So basically, all this is telling you, this giant paragraph, is that the unit tests, they're implemented as classes with test methods. These test methods, they're just for single methods. So if you're trying to test multiple methods, you got to split the tests. Now we have another a JUnit test for classes example. We're importing the JUnit and the static org JUnit insert. Now I have my class, and this is my unit test. Right? Now I have my unit test. Now in my unit test, I have at test, right? The annotation at test. So I'm saying this is a test. It's gonna run now, and now I'm doing test concatenate right here. My unit, unit, my unit. And now the string result is my unit concatenate, and insert equals is now my insertion method that I'm testing. 1 and 2 are equal, and the result is perfect. Now we're using our annotations, we're using our assertions, and we also have, this is a full JUnit example of our test. Alright, so you have JUnit test for the class that's continued, the same thing as what we were just doing before in the last slide. We use the JUnit test to use the method test concatenate. We use annotations. Yeah, this is just basically saying what I just told you guys already. If we did not have that, then the code would not be executed by the test runner. Yeah, we know that because we have to use our assertions and annotations. That's what we learned because now we're importing this specific library into our program to help us test things. When we use the assert equals method to test if the concatenation is true, if the method returns true, nothing will happen, which is exactly what we want. But if it returns false and exceptions thrown, the test method stops executing. There are more test methods in this class that can be used for all types of methods. So we could, if you ever want to look at it, we could look for all types of methods. So let's talk about exception handling. We got a couple things when it comes to exception handling in JUnit. There are 3 ways to handle an exception, right? Like let's say we have this exception right here. Everything else is perfect. It's facing the right way, and this one, this guy right here, it's facing this way, and that's a no. We don't want that. So in JUnit, there's 3 ways to handle exceptions. We have the try and catch idiom, the JUnit rule, and annotations. So for the try and catch idiom, this is one of the most popular ways. Now let's break down this code. We have our test annotation. Now, we're saying throws exception when negative numbers are given, right? We're saying try calculator add -1, -2, and 3. Fail should throw an exception if one or more given numbers are negative. And catch is exception-y. Right here, exception-y. Assert that is the instance of illegal argument exception class. Has message negative not allowed. In the above pros, the test will fail when no execution is thrown. So we're basically saying when no exception is thrown, and the exception itself is verified with a catch clause. So if the exception is verified right here from this catch clause, we have the JUnit rule. The same example can be created using exception rule. The rule can be a public field marked with @rule annotations. Please note that the thrown rule may be reused in many tests. JUnit rule also makes the code more readable. So we have @rule, the annotation. We have public expected exception thrown, and the expected we declared none so far. Now we're doing it in the test. We have the rule. Void throws exception when negative numbers are given. Thrown to expect illegal argument exception dot class. Thrown expect message equal to negatives not allowed negative. And then here we have the calculator. So when the exception isn't thrown, you'll get the following message. Java.lang.assertion error expected test to throw an instance of Java lang illegal argument exception, an exception with message negative not allowed. Pretty nice. But not all exceptions I check with the above approach. Sometimes I need to check only the type of exception thrown, and then I use test annotations. Annotation is when the exception wasn't thrown, you will get the following. Java this message right here. You'll get this following message if the exception is not thrown. And with this approach, you need to be careful. Sometimes it's tempting to expect general exceptions, runtime exceptions, and even throwables, and this is considered as a bad practice because your code may throw exceptions in other place than you actually expected, and your test start will still pass. Should the unit test be solitary or sociable? So imagine you're testing an order classes price method. The price method needs to invoke some functions on the product and the customer classes. If you like your unit test to be solitary, you don't want to test the real product or customer classes here, because a fault in the customer class would cause the order classes test to fail. Instead, you use test doubles for the collaborators. For sociable testing, often to test units relies on other units to fulfill its behavior. And then we also have for solitary tests, some units testers prefer to isolate the tested unit. The same page continues. The common properties of unit tests: small scope, done by programming itself, and they're fast. They can run frequently when programming, and this is one of the characteristics of self-testing code. In this situation, programmers run unit tests after any change to the code. That way, you could constantly verify. If you make a change, you had existing code, you worked for, you know, FANG company like Facebook, Amazon, Google, all these types of companies. If you're gonna just inject some kind of new code, you want to make sure that all of the unit tests are making it work. Because if you don't do that, then all of a sudden, all this code is not good. And these companies will fire you. Yup, they will fire you. So remember not to do that. Alright, so we're going to talk about testing with mock objects. We can use mock objects to test our code. You can use JMock's library for defining mocks. JMock is a Java mock object library. There are no other mock object libraries out there, but this one is up to date. The setup phase is very different, divides into two parts: data and expectation. The data part sets up the objects we are interested in working with. The difference is the object creation. The second part created expectations on the mock object. The expectation indicated which method should be called on the mocks, which when the when the SUT is exercised. So we also need to verify the mocks, and we're checking that they were called according to their expectations. With state verification, we do this by assert against the warehouse's state. Mocks use behavior verification when we check to see if the order made the correct calls on the warehouse. Alright, so let's see how we use easy mock. Let me just drink some water real quick. How much time are we in? I don't want to make this video too long. We're already at 34 minutes. Oh my god. We still have a lot to go. So we can use easy mocks. There's a number of mock object libraries out there. One of the examples is easy mock. It has both Java and Net versions. Easy mock also enable behavior verification, but it has a couple of differences in style with John. With this, for each object you wish to mock, you create a controller mock object to indicate any expectation. You call the method and arguments that you expect. Once you finish setting expectation, you can replay on the control, at which the mock finishes the recording and is ready to respond to the primary object. It's great. It's pretty versatile. The differences between mocks and stubs, many people get easily confused between mocks and stubs. When you're doing tests like this, you're focusing on one element of the software, hence the common term testing. The problem is that to make a single unit test work, you often need other tests, hence the need for some kind of warehouse. In our example, this is like the tool style test we talked about using mocks. Testing doubles. Test doubles are generic terms for any kind of pretend object used in place of real objects. So we have these test doubles, right? Now let's talk about test doubles a little bit. We have these genetic terms that pretend objects used in place for real objects for testing purposes. We have the dummy objects, we have the fake objects, the stubs, the spies, and the mocks. And so the dummies, they're objects that are passed around or actually used. Fake objects actually have working implementation, but usually take some shortcut. Stubs provide canned answers to calls during tests. Spies are stubs that also record some information. Mocks are what we were talking about for the most part in the slides. One of these kinds of doubles only mocks assist upon behavior verification. The rest don't. Classical and mock testing. There's the classical test-driven development. User is still use real objects if possible, and a double if it's awkward to use the real thing. So a classical test driven test driven developer would use a real warehouse and a double for the mail service, the kind of double that doesn't really matter. I put that much. A mockist test driven developer practitioner, however, will always use mock. Let me just charge my laptop because it's about to die on me. They'll always use interesting behavior. In this case, they're both warehouses and mail services. So now, choosing between the difference, the first thing to consider is the context, right? What are we talking about? What kind of thing? Is it a warehouse, an awkward one, such order, mail service? If it's easy collaboration, then the choice is simple. Some people say, well, here Martin Foiler says, I am a classic, right? But me personally, I don't know what I am yet. But so far, from what this expert says, he is a classist. And if it's awkward collaboration, then there's no decision. Then you got to be a mockist. So there's test-driven development is the techniques for building software that guides software development from writing tests. It was developed by Kent Beck in the late 1990s as part of the Extreme program. And in essence, you're following three simple steps: write a test for the next bit of functionality you want to add, write the functional code, unit until it's patched, refactor both, and you're good. So it provides two benefits. You get self-testable code, and the second benefit is that you're thinking about the test. It forces you to think about the interface and the code first. The most common way I hear is people screw it up is screwing up the third step. So what makes a good unit test? Test should reduce risk, not introduce it. Test should be easy to run. Test should be easy to maintain, and the system evolves around it. Test should only fail because of one reason. Test should only test one thing. Minimize test dependencies. So units versus functional integration tests. We're cutting it really close. So we're going to make this short. Unit tests ensure that the individual component of the app is where work is expected. I'm sure you guys could pause the videos if you want to watch any of these slides and read it. Integration tests ensure that the component collaboration work are expected. Functional tests ensure the app works as expected. So for during development, for developers' feedback, unit tests are particularly helpful. In staging environments to detect problems and stop to deploy process if something goes wrong. In the production environment, subset of production safe functional tests. Which types to use? All of them. Use all of these. They're great. In order to understand how different tests will fit into your software development process, you gotta think about this stuff when you're writing code. Think about the testing, and it will also help you write the code. User experience, right? Developer API test, infrastructure, developer experience test, developer API test. There's the unit test should be dead simple, lightning fast, good, easy box. A failing unit test should tell you which component is under test, what is the expected behavior, what's the actual results, what is expected results, and how is the behavior reproduced. So with the integration test ensures the various unit tests work together. Functional tests are automated tests which ensure that the application does what it's supposed to from the point of view of the user. Smoke tests after you deploy a new release on the product, it's important to find out whether or not the product's working correctly. And continuous delivery. Prior to continuous delivery, Revolution software would be released using a waterfall process. Software would go through the following steps one at a time, all of this. In theory, in reality, a lot of project scopes discovered as projects being deployed, so you're continually delivering. And then we have the continuous delivery solution, or here is developmental methodology, which we talk about as while you're writing code. You should be thinking about this is incremental improvements and softwares in short cycles. So this way, continuous delivery, we're constantly thinking how we can improve and not thinking about writing all this code and then how do we maintain it. No, how do we fix this? How do we maintain this? How do we make this better? How do we do this? With continuous delivery, shapeshift, and is all that. As you can see, each type of test has an important part to play. Alright, so these are the external resources if you guys want to see some more about U of JUnit, JUnit 5, also about mocks, and these are the references, that help me make these slides and the information I've used and how I try to teach you guys about unit testing and a type of unit testing, JUnit. And a little bit more right here. These are my references. And yeah. All right, everyone. Thank you so much for watching. Discard.